Hey guys, I just wanted to share an assignment, an activity that I've been doing with my kids, and I think it's pretty cool. Um, and what I had them do was mess around with Geogebra with this app that I shared with you guys, made a little podcast on, it's like a 5-minute podcast. But anyways, I spent 2 days in class walking the kids through the app, talking about how we can change the zero term, the difference. The n is for when we evaluate terms, and when we look at all these vectors. Get that out of there. We got all these interpretations. We got the algebra that's always working dynamically with the pictures here. So really seeing the geometry connected to the algebra. This is what I think integrated math is all about. But anyways, we messed around with that, talked about this number line, being the vector addition, really what this rule is saying. We have, since I'm solving for n, 7 vectors that are 1.75 long, right? So we can see that, add that to our zero term. So there's our output value. Also the vector showing how we, when we try to identify the 7th term, we just follow the x-axis to 7, go up till we find that point, and then this dotted line, I tell my kids it's a reference line. It's helping their eyes see how to read a graph efficiently so that they can get good at this. And then we got the other vector notation shown as x increases by 1, we add our difference. X increases by 1, add our difference. So we got slope concepts shown here. So anyways, what I decided to do was start giving them rules, and they had to change the zero term and the difference, and then I gave them a couple points to evaluate. So I made a worksheet for that. It looks like this. Mine didn't look like this, I just made it. Um, but I use these same equations here. So I just converted my n to x, and I told my kids I didn't want to write the t sub n because there's extra keystrokes in there. So I'm just going to change the variable to y, kind of work with the sequence, and then I just made a pretty big jump to notation for our line stuff, really. See how that goes, I'm not sure. But anyways, I wrote the instructions here. So for each equation or number pattern, use GeoGebra to set up the graph for the equation. So like number 1, let's do this together. Then you're going to manipulate the window so that you can see the solution point and both axes on our window in GeoGebra. Take a screenshot of each picture showing the evaluation point, and then finish the term value statement, which is this highlighted one, by typing in the term value for the indicated term number. Okay, so each problem, there's 5 of them. They're each a different equation. What they're going to do is they're going to set up their GeoGebra to show the graph of this equation. So they have to identify what the b is and what the d, which I'm calling difference. I can show you too in this video real quick how you can change that to m if you want to do slope or whatever. But I've just been using difference and slowly building my variables to look like the slope-intercept equation. But anyways, so we're going to do this, and then we're going to evaluate for the 16th term and the negative 10th term, and then I'm going to just fill out these equations. So 16th term is, I'm going to write what it is after I find it. So if I'm a student, I'm going to change my, what did we have here? Negative 5x minus 10. So I'm going to change my b to negative 10, right, which you could slide, or you can just take your, just type it in the box here. We have negative 5. Okay, so with my kids, and then we're going to evaluate the 16th term. So I'm going to slide my n to 16 or type it in. So it's off the graph here. So I tell my kids I want to see my axes because I need these numbers for reference. Otherwise, like I just show them this, these points right now, they mean nothing to me. I can see a pattern, but I don't have any numbers to use. So when we show the window, I want to see both axes here, and we can see the numbers work down. Here's our 0 at term value, right? That's our negative 10. And then since we're finding the 16th term, we've got 16 of these negative 5 vectors, again, connecting it to the math here, showing the evaluated point. I already know the 16th term is at negative 90, so students can see that. So I want to get all the way down here. I can see my 16th term on the x-axis. I want to get all the way down here, but I want to keep my axis. So to do that, instead of now that I'm trying to find the point, my x-axis is gone. So to do that, what we do is we just have our Move Graphics tool, and we just click on the y-axis, see how the hand turns to arrows, and drag it towards the origin. All that does is change scale. So now we can see our solution point, and we can use these vectors. Again, we're going to go out to the 16th term, down to this point right here, which is representing the 16th term and its value. Here's negative 80. That must be negative 90, which is shown by the algebra. So now that they have that shown, I want them to hit print screen on their keyboard. With these laptops that we have at school, it's just above the backspace button. And if they hit that, I let my kids know that nothing's going to happen on theirs. Oops. But I have green shot on mine, so it's a little different. So when I hit print screen, um, I have to actually capture the screen. But the kids don't have that. So then when they hit print screen, nothing happens, but it saves the picture to the clipboard. So that's what I just did. So for number one, where it says paste screenshot here, I'm going to highlight over it, and I'm just going to paste over top of that. So here's my screenshot of the 16th term. It's negative 90. So now I can just type in here, negative 90. I want the kids to understand and make the conscious effort of actually saying what the term number, is, the solution is for our input. So then they just go to the next one. Now they're going to keep the rule, but they're going to evaluate the negative 10th term. So all they have to do is understand that they keep the pattern, but to find the negative 10th term, we just slide our n or type n to be negative 10. And then I'm going to use my move graphics view to move my grid around. There's my point. I don't even have to do any more scaling, but we could if we want to, you know, see the pattern better. But anyways, there's my picture. So I'm going to hit print screen again. I'm going to identify from the algebra or the graph that my negative 10th term is 40, right? So copy to clipboard. I'm going to paste over my screenshot. I'm going to paste it, and then I'm going to finish my equation. The negative 10th term is 40, okay? And then we go to problem two. So they have to re-identify a new b and a new difference, set up this number pattern, and show the term values for those with their GeoGebra window. So then when they're all done with that, they do all 5 of that. Then they're going to save it. So I'm going to save mine as Bowers example. Okay, so I'm saving my documents. Now, once they get that saved, all they have to do to give me their assignment is go onto their Edmodo account, which I've been using. I set up a homework assignment here. They just click, this is a student's view, by the way. I made up a BHS student. So they just click turn in. Then they just click this little file icon here, and they just attach, that's their attach button. So then they just attach their document, Bowers example. And then they have to rate it. So they either type a response or they type one of these things. I doubt the kids take these serious, so they're just going to click one just to send it. I don't think that means anything. Um, I guess they don't really have to. That warning comes up. I thought they did. So now the kid had submitted. So it shows the student that they submitted their document. And then on my end of Edmodo, I can see that, grade it, and I can actually make comments on it and send it back to them. So anyways, that's an activity that I did in class with my students. So if you have any questions about that, let me know. But I think it's pretty cool. And the students are doing mathematics, and they're actually manipulating and seeing graphs change. So I do believe it's worth the time. And yeah, pretty cool activity. Hope it pays off. Thanks, guys. Bye.